Hello everyone, welcome to the MRU E-Learning powered by the Malla Reddy University. My name is Shraddha Verma, Assistant Professor in AI and ML departments. Today I am going to discuss about the deep learnings, which is a sub-branch of the machine learnings, and the structure is inspired by the brain structures. In the brain we have the different types of the neurons. The neurons, if we consider one neurons, the neurons consist this axon terminals, axon bodies, and the dendrites. So the neurons follow the structures like the sensory. Then it will go to the mid or the low levels neurons. Then in the higher level cortex regions of the brain help in the decision making. So these brain structures we want to mimic artificially. So we need this type of the flow chart. First we need to input the input signals that from there we will select the features, and from there we will learn something that machine. Then after learning that, the decision will be taken by the machine. So this artificial flow chart is followed by the machine. So the basic building block of artificial neuron is known as the perceptrons. Perceptrons consist of the different input values, associated weights, and the bias. After summation, we will get the some output, which is here we are calling at induced field, and then it is fed to the activation functions. Thereafter, we will get the final output. So there are the different types of the activation functions which help in selecting the different outputs. So the activation function like the step functions help in the binary output. Binary output means 0 or 1 or -1 or 1. The second type of the activation function is the ramp functions, where the gradually we select the output. So the input and output here are related. In the sigmoid activation functions, the activation function will be look like this, and it will select the activation function. Sigmoid activation function will be look like so it could be 1 and it could be -1, or from the 0 to 1. Next is the Gaussian functions that based on the radial basis functions, and it select only the positive output. So the range will be lie between the 0 and 1. Next is the sigmoid unit. After using the activations function, sigmoid activation function, we will get this type of the perceptrons. And here I have chosen the bias whose value is 1. Most of the deep learning models use the sigmoid activation function because it is smooth and it is easily, we can easily derive it. So it helps in the in getting the linearly separable problems, and we can apply the gradient descent rule here. But this type of the model is failed in the case of the complex problem, or where there is a need of the non-linear separable problem. So for that, we need to shift to the feed-forward neural networks. So feed-forward neural networks or the multi-layer here I am using. So this means it will consist many layers. The basic layers any feed-forward neural network include is the input layer, hidden layers, and the output layers. The hidden layers could be 1 or more than 1. Basically, this type of the structures is known as the ANN, artificial neural networks. If the hidden layers are more than 2, that come under the deep neural network. So feed-forward neural network help in overcome the limitation of the single neural networks by handling the non-linearly separable task. So in the feed-forward neural networks, the direction is from the input to the output. So at the output, we will get some error, and that error, to minimize that error, we can use the backpropagation methods. The backpropagation methods use the direction from output to input. So in the backpropagation methods, what we are doing, initially in the feed-forward networks, whatever the base biases and the weights we selected is randomly selected one. So we need some type of the algorithms which help in optimize the weight and the biases of the model. For that, come to know one algorithm, that is the backpropagation algorithms. In the backpropagation, the training is from the output to input, and here we find the derivative of the weight and the derivative of the weight and the derivative of the biases that help in minimizing the error at the output. After that, we will get and select different types of the output and the different types of the weight and the biases that provide the satisfactory output. So basically, if you want to train any deep learning models, we need to select some data, sample data. Then we will feed that data into the deep learning models in the forward directions. Then after, we will get some error at the output. That error will be minimized by the backpropagations. And that backpropagation, how it minimized? By updating some weights or biases. Next is the choice of the architecture neural networks. So how we will choose the network, deep neural networks? We should choose some deep learning networks which lies between which does not show any underfitting or the overfitting problem. Underfitting problem mainly happen when the less number of the hidden layer use. Overfitting problem happen when more number of the hidden layer use. So our job here is to select some models which is not overuse the hidden layers and not underuse the hidden layers. And it should be such that the error and the complexity will be in the minimum mode. So the basic deep learning neural network is the convolution neural network. So convolution neural networks consist of mainly feature extractions, classification, and the output. So in the feature extractions, when we feed any input to the layers, so it consists of the layers like the convolution, value activation function, and the pooling layers. This complete block is known as the convolution blocks, and different blocks we use for extracting the features map. After extracting the features, which is in the 2 dimensions, we flatten that into the 1D array. Then for the classification, we use the fully connected layers. Fully connected, as the name is showing, all the inputs are connected with the outputs. So this will help in the classifications. After using the final activation functions, we will get the output. So here we can say, here we choose some image which is zebra. So at the output, we will get the value, high value, that is 0.7 for the zebra. For the other classes like horse and the dog, the value will be less. So basically, for the multi-class, we use the softmax activation function, and for the binary class, we use the sigmoid activation function. Next is the convolution layers. So convolution layers help in the feature extractions of any image. So suppose if input image has the dimension 224 cross 224. So after using the convolution layer, the dimension x and y dimension will remains the same, but the depth will be changed according to the numbers of the filters we used. Next is the max pooling layer. So this layer help in reducing the dimensionality. So in the max pooling layer, what we are doing, we are selecting the maximum value instead of selecting all the values of the window. We select only the maximum value. So this maximum value will provide the relevant features, and the irrelevant features we don't consider or make it as a 0. So in the max pooling layers, if the dimension is 224 cross 224, it will reduce to 112 cross 112, which is basically a downsampling. So after using many convolution blocks, which consist of the convolution layer, value activation function, and the max pooling layer, we will feed that final features into the fully connected layer for the classification. So here we can see the 2 dimension now changes into the 1 dimension array. So suppose if we have the image of banana, after passing with the different convolution blocks and the fully connected layers, we will get the output in the form of the probability distribution. So the total probability is 1 here. You can sum it, it is 1. 0.2, 0.4 plus 0.9, 0.01 and 0.3. It is equal to 1. As the input here is banana, so the highest probability is of banana, and other classes will get only the low probability. So in this way, we are able to select the suitable output. So how and what are the hidden layers learned in the deep learning method? We have some image here. Here, suppose we have I'm using the image of the car. So the car has yellow color, wheels are in the black color, and it is circle. The shape is circle. So there are the different types of the features is extracted by the hidden layer, like low level features, mid level features, and the high level features. So the low level features include the color, textures, and the mid level features include the patterns. The high level features include the object. After getting these types of the features, the classifier job is to classify the data into the different categories. Number of the hidden layers is depend on actually provide the accuracy or the performance. So if we use suppose 3 convolution layer, so the accuracy will lie only 93%. But if we use 11 convolution layer, the accuracy suddenly increase and it will increase up to 96. So if we use more nodes, the accuracy more nodes, the accuracy will, so if we use less hidden layers, that type of the network is known as the shallow networks. If we use more hidden layers, that type of the network is known as the deep neural network. But there are some challenges after using the many hidden layers. The challenges like overfitting problem, vanishing gradient problems, accelerating training, and the hyperparameter tuning. So the overfitting problem we can overcome by using the dropout. So the dropout is in the we use in the fully connected layers, where we will select only 0.5% of the connections, and rest 0.5% we will ignore. And the vanishing gradient problems we will overcome by using the value activation function. Similarly, the accelerating problems can be overcome by the batch normalization. So in the batch normalizations, we select the different batches and of the sample data. And after that, the next problem is the hyperparameter tuning problems. It is based on the hit and trial method. So the hyperparameters is like learning rate, number of the neurons is come under the hyperparameters. We need to select the typical value of the learning rate between the 0.1 to 0.01 and the number of the neurons from the 10 to 1000 in most of the cases. Next is the ResNet, that is the residual network. So this is the variations or the modified CNN, you can say. So here the CNN is the basic block, and in the basic block we are using the skip connection. So this residual network help in overcoming the degradation problem of the neural network. So these type of the networks are trained by using the ImageNet. The ImageNet is the data set where approximately 4 million of the images existed. So most of the deep learning models are trained on this ImageNet dataset. Next is the computational complexity. So different structures of the deep learning neural networks has the different complexity. So the lowest complexity neural network is the LXNet. And the highest complexity deep learning model is the Inception's V version 4. And the ResNet lies between in the middle of this. So based on the different application, we will use the different types of the deep learning models. Suppose the RNN, that is the recurrent neural networks, and the LSTM, that is the long short-term memory deep learning models we use for the time series or the sequence data. Autoencoders we use for the representation learnings. Autoencoder mainly consists of the encoder blocks, latent space, and the decoder. So from the encoder, the data is encoded into the latent space, that is the low dimensionality. Then after that, from the latent space, the data is decoded by the decoder. Next is the GN model. GN model is used for the classification and the distribution learnings. It consists of the two models. One is the generator, second one is the discriminator. So the generator job is to generate the data, and the discriminator discriminate the data or find the difference between the generated and the real data. So based on this, the classification can be performed, or the distribution learning also can be performed. Thank you.